So my dear students, welcome back to this session. In the previous session we had seen how to draw influence line diagrams from the first principle for the reactions, for the bending moment and shear force at a section. Now in this session what we will do is we will see how to draw influence line diagram directly in a very shortcut manner, so that the influence line diagrams which are drawn in a very easy and shortcut manner can be used for simple applications. So let me take a beam and I will tell you how we can draw the influence line diagram. It's very simple, you can understand. Say this is the beam, simply supported beam of span L. This is support A, this is support B, and say this is section C at a distance A, small a, from support A. So we had seen how to draw influence line diagram for bending moment and shear force at section C from the first principle. Now we will see how we can draw influence line diagram for bending moment and shear force in a very simplified shortcut manner. For that, let me draw first, see here, influence line diagram for shear force at C. So for that, what is to be done is take a horizontal line of length equal to L, and then this is L. Take a horizontal line of length equal to L, it's very simple. And after that, erect 1 kilonewton here, because we have seen that influence line diagram is drawn for unit forces. That means unit load is allowed to move. Erect 1 kilonewton down here. So now join this line and join this. Now you can understand that these two are parallel because 1 kilonewton, 1 kilonewton. And wherever section C is there, mark a point there and cut a line here like this. Now join this. This itself is influence line diagram for shear force at C. Now how to find out this ordinate? This is positive diagram, this is negative diagram. This is what we had got. Now how to get this ordinate? To get this ordinate, you know what is slope of this line. Slope of the line, slope is tan theta. Tan theta equal to opposite upon adjacent. Opposite is 1 kilonewton. Adjacent is L, 1 by L. So slope of this line is 1 by L. Slope of this line is also 1 by L, because it is 1 divided by L, tan theta. Now what is this ordinate? Slope of the line into the distance. What is this distance? This is A. You can see here, this is A. So what is this? This is L minus A, right? Because total is L. So what is this ordinate? This ordinate is equal to slope of the line into the distance, into the horizontal distance on this side. So it is 1 by L into L minus A, or L minus A upon L. What is this ordinate? This ordinate is equal to slope of the line. Slope of the line is 1 by L into A. So this ordinate is 1 by L into A, and this ordinate is 1 by L into L minus. If you add both ordinates, you can see it is equal to 1 kilonewton. 1 by L into L minus A plus 1 by L into A together, in magnitude it is equal to 1 kilonewton. This is how you can draw influence line diagram for shear force at C. I repeat again what is to be done. Draw a horizontal line which is equal to L. That is, the length of the line is L. Erect 1 kilonewton top here, erect 1 kilonewton bottom here. Then join this line, these two are parallel, and then cut at the point where you want to draw the influence line diagram for shear force at C. That is at a distance A. Then darken this. So this is influence line diagram for shear force at C. It has positive zone and negative zone. Positive zone is this, and how to get this ordinate? The slope of this line first is to be obtained. The slope of the line is 1 upon L. And slope of the line into the distance, this side, 1 upon L into L minus A is equal to ordinate this side. So ordinate, lower ordinate or negative maximum ordinate is slope of the line, again same, because it is 1 upon L into A this. So this is how we can draw influence line diagram for shear force at C. So now let us see how to draw influence line diagram for bending moment at section C. For that, what you need to do is again draw a horizontal line which is equal to L again, because the span of the beam is L. And here on the left side, you can see left side section C is at a distance A. So on the left side erect A. That means A is the distance. And on the right side, erect the remaining distance of CB. How much it is? L minus A, right? L minus A. So this is ordinate is A, this horizontal ordinate, so this vertical ordinate is L minus A. Now join this from the top of this line to the bottom of this line. Then join this, where the section C is this side. You can see. Join this. Now darken this. And this ordinate is to be found out. This itself is influence line diagram for bending moment at C. This is how it was. We have seen in the previous session, like how we found out influence line diagram for bending moment at section C. It had only positive and positive zone, no negative zone. Whereas here it was negative and positive zone. Now how to find out this ordinate? To find out this ordinate, see here, what is slope of this line? Slope is equal to tan theta, which is equal to opposite upon adjacent. A opposite, because this ordinate height or this height is A upon L. And what about the slope of this line? L minus A upon L, because this is L minus A upon L. So what is ordinate of this? This ordinate is equal to slope of this line into distance. This is A. You can see. This is L minus A, you know already, right? So this ordinate is equal to, I will write it here. You can see slope of this line, that is A upon L into L minus A. A upon L is the slope of this line into L minus A. Or if you take this line, what is slope of this line? L minus A upon L into A. You can see A upon L into L minus A or A upon L into L minus A. Again, this is how you can draw influence line diagram for bending moment at C. So this is the direct method of drawing influence line diagram for shear force at C and bending moment at C, and these two are very, very important, my dear students. It is because using these we are going to do certain simple problems. We are going to see the application of the influence line diagram for bending moment and shear force at C. Like, instead of, because influence line diagram is drawn for unit load, instead of unit load, if there are some other loads which are moving from one end of the beam to other end, how we can make use of these two diagrams in finding bending moment and shear force for that particular position at section C. This is very interesting. So this is very important.